What is the radius of the circle, and the area of the red triangle inside the circle? From the figure, AB and CD are chords of the circle, both chords are perpendicular to each other, and O is the center of the circle. To find the area of the red triangle inside the circle, we need to find the radius of the circle. First, we are going to find MD using chord theorem since AB and CD are chords. From chord theorem, MA times MB equals MC times MD. Let's plug in the value of MA, MB, and MC, which are 8 cm, 12 cm, and 6 cm in this formula. It follows that 8 times 12 is equal to 6 times MD. To find MD, we divide both sides by 6. On the right side, 6 will cancel out, on the left side, 12 divided by 6 is 2. And this will leave us with MD equals 8 times 2, which is 16 centimeters. Next, let's draw perpendicular lines from O to MB and also from O to MD. Let's call the points of intersection, P and Q. Observe that OP equals MQ, which is equal to CD minus MC plus QD. But QD equals CD divided by 2. Reason: a line from the center of a circle that is perpendicular to the chord also bisects the chord. CD is 16 plus 6, which is 22 centimeters, and 22 divided by 2 is 11 centimeters. Hence, OP equals 22 minus 6 plus 11, which is 5 centimeters. BP equals AB divided by 2. Reason: a line from the center of a circle that is perpendicular to the chord also bisects the chord. But AB is 8 plus 12, which is 20, and 20 divided by 2 is 10 centimeters. Now that we have known the value of OP and BP, we are going to apply Pythagoras' theorem in triangle BOP to find BO, which is the radius of the circle. From Pythagoras' theorem, R square equals OP square plus BP square. OP is 5 centimeters, and BP is 10 centimeters. It follows that R square equals 5 square plus 10 square. 5 square is 25, and 10 square is 100. So, R square equals 25 plus 100. Which is 125. Taking the square root of both sides will leave us with R equals square root of 125, which is 5 root 5 centimeters. Going further, observe that triangle BMD is also a right-angled triangle. Let's apply Pythagoras' theorem to find BD. From Pythagoras' theorem, BD square equals MB square plus MD square. MB is 12 centimeters and MD is 16. It follows that BD square equals 12 square plus 16 square. 12 square is 144, and 16 square is 256. So, BD square equals 144 plus 256, which equals 400. Now that we have BD square as 400, let's find BD by taking the square root of both sides. It follows that BD equals square root of 400, which is 20. Hence, BD is 20 centimeters. Next, let's draw a perpendicular line from the center of the circle to line BD. Let the point of intersection BF. Recall that perpendicular line drawn from the center of a circle to a chord bisects the chord. It follows that BF equals BD divided by 2. BD is 20, so 20 divided by 2 is 10 centimeters. Since triangle OFB is also a right-angled triangle, we are going to find OF using Pythagoras' theorem. So, from Pythagoras' theorem, BO square equals BF square plus OF square. Recall that BO is the radius of the circle, which is 5 root 5 centimeters, and BF is 10 centimeters. It follows that 5 root 5 square equals 10 square plus OF square. 5 root 5 square is 125, and 10 square is 100. So, 125 is equal to 100 plus OF square. Next, we take 100 to the left side. 100 going to the left will become negative since it is positive. It follows that 125 minus 100 equals OF square. 125 minus 100 is 25, and 25 equals OF square. Taking the square root of both sides will give us OF equals square root of 25, which is 5 centimeters. Recall that area of a triangle is 1 divided by 2 times base times height. Which implies that area of triangle BOD equals 1 divided by 2 times BD times OF. Since BD is 20 centimeters, and OF is 5 centimeters, then, area of triangle BOD is 1 divided by 2 times 20 times 5. 20 divided by 2 is 10, so we are left with 1 times 10 times 5, which is equal to 50. Hence, area of the red triangle is 50 centimeters square. Please subscribe to my channel to encourage me to make more videos. Thanks.